Okay, today we're going to learn 5.2, which is exponential functions. Y equals AB to the x is an exponential function. The A stands for the initial value of where your graph starts. The B will let you know if your graph increases or decreases. If it's less than 1, it's going to decrease, and if it's greater than 1, it's going to increase. So I'm just going to give you a basic parent graph of what this should look like, and then we're going to do more graphs later on in our notes. So 1 is the initial value. I'm going to start it at 1 then. The 3 lets you know if it's going to increase or decrease. Since the 3 is greater than 1, it's going to increase. There's also an asymptote in this problem. The asymptote is always at 0 until you shift your graph. So I know we studied these before in Algebra 2, but this is what an exponential graph looks like. Okay, the next part, the shifting of an exponential graph. This part will move it up or down. And this part will move it side to side, just like you shift other graphs. I want to do one extra one just to show you another one, and then we're going to do more in the section. I'm going to do y equals 3 raised to the x minus 1 plus 2. Y equals 3 raised to the x minus 1 plus 2. Do you notice they have a b, but they don't have the a? So the a must equal 1 in this problem. So we're going to start our initial value at 1. It's going to get shifted up 2. And it's going to be shifted to the right 1. So this is what your graph looks like. You start at 1. But that's not going to be your actual spot, because you're going to shift this 1. You're going to go up 2 and to the right 1. This is my new spot that my graph is going to go through. Again, once again, I start at 1 because that's my initial value. I'm going to shift it up 2 and to the right 1. Okay, now comes the tricky part. You also have to shift your asymptote. Remember, your asymptote starts at 0, but instead I'm going to move it up 2. So it's going to be right here, up here at 2. Your dot moves, also your asymptote moves. Since 3 is greater than 1, your graph is going to increase. We're going to do more of this graphing in another section. This was just supposed to be the introduction. Okay, part 1. We had these in Algebra 2. These base numbers are very important that you know your base numbers. 1 to the first is 1. 1 to the second is 1. 1 to the third is 1, and so on. You need to know your 2's and your 3's out to the 5. You need to know 2 to the 5th is equal to 32. You just have to know that. You need to know that 3 to the 5th is equal to 243. Those are the big ones. These two are the big ones because these are the most popular base numbers. Your 5's, you only need to know up to 5 to the third. Your 6's, 6 to the third, and so on. But the middle ones, the base 2 and base 3 are your big ones. That's why you have to know them all to the 5th power. So the idea of solving these type of exponential equations is you need to have your base numbers look the same. If the bases are the same, which they are, they're both 6's, there's a rule in math that says you can cross them out and set your exponents equal to each other. I'm going to cross the 6's out and just set your exponents equal to each other. And now solve for x. I'm going to subtract x to both sides, and I get x equals a negative 3. Final answer. Now it's going to get tougher in the next problem. Now your base numbers will not be the same, and we're going to do a whole bunch of these problems. I've got 3 problems where my base numbers are not the same. So let's look at number 2. If you look at number 2, You have one that's a base 3 and one that's a base 9. You always go down to the lowest base number. And 9 isn't even a base number, so you know you have to go down to base 3. So I'm going to write my 3 down as 3 raised to the 5x minus 8. My 9 I'm going to change to 3 to the second power, because that's what 9 stands for. And I'm going to still keep that x plus 2 up there. Now at least my base numbers are the same. And the rule says that if your base numbers are the same, you can cross them off, and you can set your exponents equal to each other. I'm going to change this other exponent to 2x plus 4. I'm going to subtract 2x and get 3x equals 12. X equals 4. Okay, the next one's getting harder. You have to scan your problem and decide what your base number is. You scan your problem, and on the left-hand side there's a 4, and on the right-hand side there's a 1/8. So you need to figure out what base number you're going to work in. And the base number you're going to work in is 2. There is no base number 1/8. There is no base number 4. So the lowest base number you can work with is 2. I'm going to change the 4 to 2 to the second, and I'm going to copy down the x plus 2 next to it. Equals. Okay, now we have to go all the way back to chapter 1 and understand what 1/8 stands for. 1/8 is the same thing as 2 raised to the negative 3 power. Remember, negative exponents don't make negative answers, they make fractions, and we did this in the first chapter. You should know that 2 to the negative 3rd power is 1/8, and you still have an x minus 3. Did we get the base numbers to look the same? Did we get them down to a base 2? We have them down to a base 2. The rule says cross off the 2's and set your exponents equal to each other. Solve for x. 5x equals 5, x equals 1. Final answer. Okay, next problem, number 4. You look at it, and you're trying to figure out what your base number is going to be. And you scan it, and you decide that your base number is going to be 3. So you're going to change the 9 to 3 to the 2x times. You should know how to change 1 over 27 to a base 3. It's 3 to the negative 3 with the x plus 1 on the outside. And this whole side is already done for you. Just copy it down. It's already in base 3. Okay, there's a rule in math that says if you have base numbers that are the same, what can we do with these exponents? We can add them. So we have 3 raised to the, we can add these. And isn't this really a negative 3x minus 3? So if you add these together, you'll get a negative x minus 3 on the top. On the right-hand side, it's the same concept. Your bases are the same. You can add your exponents. That's going to give you 6 plus 2x. Now that they're the same, you can set your exponents equal to each other and solve for x. You'll get a negative 3x equals 9, x equals a negative 3. Okay, the next screen. The next screen is graphing, so I want to go over another problem with you, and then I'm going to end up doing an extra problem, because I found a problem in the book that they had a question about. So let's just do these two really quickly. Let's graph these two really quickly. The first one has a 5 parentheses 1/2 x plus 3. My initial value is 5, so I'm going to go up 5. That's my initial value right here, is at 5. It's not going to stay there though, because I'm going to move it up 3. I'm not going to shift it anywhere, I'm just going to move it up 3. There's no number after the x, so I'm just going to go up another 3. That's my real dot now. My asymptote also has to get moved up. It used to be at 0, and I'm going to move it up 3 also. So here's my new asymptote. This needs to be put in on the test. You have to have an asymptote on the test. Since 1/2 is less than 1, my graph is going to decrease. So this is what my graph is going to look like. Final answer. Your graphing calculator will do the same thing. It will not probably have the asymptote in there. You should be able to see where the asymptote is put in there, though, by looking at how that line is getting closer and closer. Okay, we're going to do this one. Our initial value is at 2, so I'm going to just put a little dot at 2. But I'm going to shift it. I'm going to shift it down 1. So instead of at 2, my big dot's going to be at 1. My asymptote also has to get moved. It used to be at 0. That also has to get shifted down 1. So here's my new asymptote. Again, I started at 2, but I need to shift it down 1. So that's where my new dot is, and my asymptote that went down 1. Since it's 1/3, it decreases. Okay, now I'm going to talk about what happens if there would have been a negative sign in the problem. What happens to the graph if there would have been a negative sign in the problem? Doesn't a negative sign flip your graph? So, if you see a negative sign in the book, what I want you to do is to graph what I just did. I need you to graph it without the negative sign, exactly what I did up there. Now, what I want you to do is all I want you to do is flip it or reflect it over the asymptote. I'm just going to flip it. Isn't this dot right here 2 up? So if I reflect it, isn't my real answer going to be 2 down? And then I'm just going to make it look like the other one. My final answer, if there would have been a negative sign, would have been in red. Again, how do I want you to do the negative ones? I want you to graph it pretending it isn't negative, and then graph it. And the final answer is in red. You would probably cross out the black part. Okay, I want to do one more and really pay attention to this because I saw this in the homework. What happens if you see y equals 2 parentheses 3 raised to the negative x power? Y equals 2 parentheses 3 raised to the negative x power. What you need to do is you need to rewrite it so that there's a 2 and there's a 3 and move that negative so that it's inside the parentheses so that it's just an x. Because the formula is only supposed to have an x on the outside. It's not supposed to have a negative sign. So really, it looks like an increased problem, but it's not really an increased problem. It's really going to be 3 to the negative 1/3, or 3 to the negative 1 is really 1/3. It's really a decreased problem. You need to watch out for this problem. If you see a negative x on the outside, you need to put it inside, and it switches the problem. I hope you write number 7 down so you know. Might as well graph it since we're having fun here. I'm going to put my first dot at 2. Since it's really a 1/3, it's going to decrease. The asymptote, nothing gets moved because there's no shift in the graph. Okay, next part. This is a very important part. You got to really listen carefully. Here are the steps in doing this, so make sure you go step by step. It doesn't matter which one you use. You can either use the first one or the second one. And how did they get the second one? I just explained how they got the second one. If you don't like the negative x on the outside, you can write it as a positive x, but then you have to put a negative 1 inside the parentheses. I don't care which one you use. The book uses this one. I'm just going to go with that one. So I'm going to use f of x equals dA to the negative x plus c. And all they want you to do is write an equation. They do not want you to graph it. So we're going to go step by step. You need 2 ordered pairs. If they give you the y-intercept is 16, write it as 0, 16. They give you the x-intercept is 2, write it as 2, 0. And they'll give you the half. Every problem, if they want you to write an equation, you need 3 things. You need this, the half. You need 1 ordered pair, and you need another ordered pair. You need these 3 things in order to come up with an equation. I have the steps over here. The first thing you do is you find your C, then you find your B, and then you find your A. You work backwards. So how do you find your C? Your C is really easy. It's just the ha. And they give you the ha as being a -2. All I'm going to do is in place of C, put a -2. Any questions? I hope you don't have questions. Just kind of see what happens with y equals a -2. Replace it. After I find the C, my next step is to find the B. How do you find the B? You use the y-intercept that they give you. They're going to give you the y-intercept. Isn't this the y-intercept right here, 0, 16? So, in place of f of x, which stands for y, I'm going to put 16. I'm trying to find the B. I don't know my A still, but I know that I can use, in place of a -x, I can use 0, plus a -2 there. Anything raised to the 0 power in math is 1. So I got rid of my A, so now I have 16 equals B minus 2. So what is B going to equal? 18. Okay, now I'm going to find my A. How do I find my A? I'm going to use the x-intercept that they give you, or the other point that they're going to give you. They're going to give you another point. So, what's the other point? The other point is 2, 0. So I'm going to do it one more time. Again, y. Y is going to stand for 0 now, because I'm using the other point. I know my B now. My B is 18, so in place of B, I'm going to put 18. I don't know what A is, so I'm going to put an A down. I know that a -x, I know that needs to be a -x, and what I'm going to use is a 2, so that needs to be a -2. And then I know my C is a -2. So everything gets filled in except the letter A. I'm going to add 2 to both sides, so I have 2 equals 18, 8 to the -2. I am then going to divide both sides by 18, so I have 1/9 equals 8 to the -2. And then we go back to chapter 1 again. You should know what a to the -2 power is. A to the -2 power does not make a negative answer. It makes a fraction. It makes 1/8 to the second. And how do you solve a fraction equals a fraction? You cross multiply. 9 equals a squared, square root, a equals plus or minus 3. So what's your final answer? Your final answer is y equals, I'm not going to use f of x, I'm going to use y equals, my b comes first, which is 18, my a comes next, which is plus or minus 3, raised to the -x power, minus 2. Final answer. You need to know how to do this for the test. So I'm going to go through it one more time so that you understand what you're doing. The first thing you're going to do is you're going to find the C. How do you find the C? Your ha will always be given. You should be able to easily figure out what your ha is, what your horizontal asymptote. After you find your C, the next letter you're going to find is your B. How do you find your B? You're going to use the y-intercept. They're always going to give you a y-intercept. You're going to plug the C in there. You're going to plug, in place of the C, you're going to plug a number. And then the letters are A's and B's, and you're going to find the B. And then the last letter you're going to find is the A. You're going to use the x-intercept, or you're going to use the other point that they give you to plug in for the x and the y so that you can find the letter A. And then you write the equation. Everybody got that? Hopefully. Okay, next screen, last screen is real world banking. Where do you find exponentials in the real world? You find exponentials in banking. A stands for the amount of money at the end. P is the initial amount of money that you're going to put in the bank. P stands for principal in banking. It's the initial amount of money that you're going to put in the bank. The R stands for the rate at which you get your interest. The N stands for your interest. How many times you get your interest? That's what N stands for. Some banks will give you your interest annually. How many times a year do you get your interest? Only once. Sometimes They give it to you semi-annually. How many times do you get your interest? Twice a year. Some banks will give your interest monthly. How many times a year will you get your interest? 12. Some banks will give it to you weekly. How many times a year will you get it? 52. Some banks will even give it to you daily. How many times a year will you get your interest for daily? 365.25 precisely, because of the leap year. The 1/4 is added in there. So, oh, I forgot the T. The T stands for the years that you put it in the bank for. So here we go. If you want to put away $3,248 in the bank for 7 years, and you're not going to touch it for 7 years, at a rate of 1.2% compounded bi-monthly, we want to know how much money you're going to have in the bank after 7 years. So, A stands for the amount of money you're going to have in the bank after so many years. P stands for the initial amount of money you're putting in the bank. We're going to put in $3,248 in the bank. Parentheses. You're going to put a 1 there. Plus. What goes on top is the rate. And right now it's 1.2%. You cannot write it as a percentage. You have to write it as a decimal. So 1.2 is 0.012. Okay, here comes the N. The N stands for how many times a year you get your interest. And in this problem, it's bi-monthly. So what does bi-monthly mean? It means that you get it twice a month, and there are 12 months. So you get it 24 times a year. You will get it 24 times a year. Okay, are you watching carefully? If N is 24, then this N is also 24 up here. And the T stands for how many years, so you're going to put a 7 next to the 24. And now all you're going to do is take out your calculator to solve this. I would do the 24 times 7 first to know what 24 times 7 is. It is 168. So this stands for 168. So now you have to do order of operation, and that is your parentheses first. You need to do 0.012 on your calculator. Divide it by 24. And just leave it in your calculator. Take 0.012, divide it by 24, whatever that is on your calculator, add 1 to it. And then after you figure out what this number is in here, what do you have to do with all of this? You need to raise it to the 168th power. And whatever that is, you leave in your calculator, and you multiply it by 3248. And it comes out to be $3,532.54. That's how much money you should have after 7 years. Is it a lot of money? No, but it's still free money by putting your money away in the bank and letting it sit there for 7 years. You know you're doing something wrong if you get something smaller than 3,248, because I hope your money should increase and not decrease. For the assignment, don't do number 11 at all. Cross it off. Don't do number 11. Do everything else on there. So, really be careful with this part. Make sure you go through the steps. How did I get my C? How did I get my B? How did I get my A? Make sure you know what you're doing. So, okay, have a good day.